we figured out by those different properties that we're talking about Kate Winslet, the actor who played Rose. Same thing with a particle. Same thing, okay? If I tell you, hey, the mass is this much, the charge is negative, the spin is this other quantity, and the spin can either be this quantity or another different quantity. The spin has a couple of discrete states. So it depends which spin state it's in, right? But once I tell you those things, you'll be telling me, okay, my guess is that it's an electron. Or if the mass is more, you might tell me, oh, okay, my guess is that it's a muon. Or if the mass is even more, you might say, my guess is it's a tau, right? Tau particle. So, or if the mass is super low, the mass is almost not there, and you're confused, like, oh my God, does this even have a mass? The guess might be that it's a neutrino. But then again, another thing is that how the particles all interact. So the particles that are electrons, muons, and taus will interact with photons. This is very important to remember. So photons are the carriers of the electromagnetic waves or light, right? So E&M, electric and magnetic fields oscillating, that's light. And photons are the quantum state or the quantum nature of light, which light has wave particle duality. Matter also has wave particle duality. So another thing too, after you kind of absorb food particles love interacting with photons. Food particles love interacting with photons. Well, yes, food is made of ordinary matter, baryons, and that does interact with photons. Yes, that's correct, Ver. I think you got it. You got it. So after you kind of digest what I just said about the mass charge spin state, quantum states of all these different particles. So I was giving you examples of electron, muon, tau, but remember that it's also possible for the quarks, the entire quark family, and it's also possible, of course, for the bosons. I keep mentioning photon as an example for boson because everybody knows the photon. It's just light. So I keep mentioning that one. But there are actually other bosons as well. Some other examples of bosons are W and Z bosons. Now, these are the carriers of the weak force. So if you've heard of the weak force, it's one of the fundamental forces. It's different. It's not the same as the electromagnetic force. It's not the gravitation force. It's not the strong force. It's another whole thing. And the carriers of that thing is the W and Z bosons. So the bosons we find are often the carriers of these interactions, and basically the particles are exchanging that boson in order to interact with each other. So oftentimes you'll see that photon is, of course, involved in interactions with things like electron, proton, all of that. And then when it comes to the neutrinos, which is a type of lepton, neutrinos are in the same particle family as electrons. When it comes to neutrinos, they don't interact with photons. So somebody just mentioned WIMPs. That's good. Weakly interactive massive particle. So somebody just mentioned, where is that comment? Thank you for 20 likes. Can we get 30 likes? Oindri Zakami. The stream is way too educational. Okay. Strongly interactive. Strongly interactive ones are called simps. So, you mentioned, Reese, I think, mentioned WIMPs, weakly interacting mass